Our next lesson is, we're going to look at lesson 19 and 20. And in lesson 19, we're going to look at non-linear systems. Non-linear meaning not aligned. Linear meaning aligned. So we're looking at non-linear systems. So this first system here, you get two equations. The first one is a circle. You get x squared plus y squared equals 9, and you get y minus x equals 1. So what we're going to do, and this is a little bit different than we've done before, we're going to take the bottom equation, set it y equals x plus 1, and then we're going to square both sides. And remember, when you square an addition, you actually write it twice, and then multiply it out, distribute it out. So you get x squared plus 1x, and 1x is 2x plus 1. This is what that equals. Then we'll take this and plug it into the y squared in the first equation. When you do that, you get x squared plus 2x plus 1 equals 9. You get 2x squared plus 2x plus 1 equals 9. Then what you're going to do is you're going to take this and plug it into the quadratic formula in your calculator. And whenever you plug it into the quadratic formula of your calculator, you're going to get two different answers. You're going to get negative 1/2 plus root 17 over 2. And then you're going to get negative 1/2 minus root 17 over 2. And what you found was the x value for two different points. This isn't multiplication, they're just accidentally touching. But if you draw a circle and you have a line that goes through it, that line is going to create two different points, two different coordinates where it crosses. And what we found was the x value for these two different coordinates. And then what you're going to do is you're going to plug in the x value for this second one. And in fact, I would go ahead and go back to where we had y equals x plus 1. Y equals, and in place of x, I'm going to put negative 1/2 plus root 17 over 2. And you're adding that to 1 when you plug that in there. And this is 1/2. So 1 plus 1/2 is going to be positive 1/2. So you're going to get 1/2 plus root 17 over 2. Same thing here. It's going to be 1/2 minus root 17 over 2. These actually aren't too bad. I know they might look it. When you take it one step at a time, review it, you'll do great. The next non-linear, once again, these are non-linear equations, meaning not aligned, not just aligned equations. These next ones that we're going to look at is a circle and a hyperbola. So you get x squared plus y squared equals 9. You get 2x squared minus y squared equals negative 6. And this actually is not going to be too bad at all because they're already lined up, ready for the y squared to eliminate. You get 3x squared equals 3. Divide by 3, divide by 3. X squared equals 1. Take square root of both sides. X is positive or negative 1. One thing that you'll notice is this is a hyperbola. This is a circle. The one thing that you'll definitely notice is there are 4 points. There are 4 places that it crosses here. And so you're looking at 4 different x comma y values or 4 different points. So we got, when we plug this in, that x is either 1 or x is negative 1. When you plug this back into, let's take the top one. If x is 1, you're going to, so you get 1 squared, which is 1 plus y squared equals 9. Subtract 1, y squared equals 8. Y equals square root of both sides, 2 root 2 when you break it down. Now what's interesting is when you're getting the square root, it's always going to be positive or negative. So when y is 1, you're going to get positive 2 root 2, or when y is 1, you're going to get negative 2 root 2. Same thing when you plug in negative 1, when you square it, it's going to be positive 1. You're going to get 2 root 2 positive, and you're going to, when it's negative 1, you're going to get negative 2 root 2. So you actually got 4 points, and it wasn't very difficult in how to solve for those. The next nonlinear equation that we're going to look at is with a hyperbola and a line. So you're going to get something like this if you were to draw it, and you get a line that goes through these. And so in these, we're going to be looking at 2 points where they intersect with each other, and you get an x comma y answer. It's always important to kind of know what it is that you're looking at so you know how many points, intersections that you are looking at with this. So when we get x, y, we're going to take this and plug it in for y here. So we get negative x minus 2 equals negative 4. You're going to get negative x squared minus 2x plus 4 when we bring it to this side equals 0. Then you're going to plug this into the quadratic equation. When you plug that into the quadratic equation for x, you're going to get negative 1 plus root 5, and you're going to get negative 1 minus root 5. Then what you're going to do is you're going to plug these in to your original deals of what you had. We'll go right here with your original of y equals negative, and in place of x, we'll put negative 1 plus root 5 minus 2. So when we do that, we get y equals 1 minus root 5 minus 2. We get y equals negative 1 minus root 5. So whenever x is negative 1 plus root 5, we get that y is negative 1 minus root 5. And you can plug the other one in, negative 1 minus root 5. So right here we just put a minus. So this ends up being a plus. This ends up being plus. So you end up getting negative 1 plus root 5. And there are your 2 points that intersect each other. Not too tough. This next section that we're going to look at is factoring exponents, or exponentials. And what we're going to look at is we have an addition happening here. We're going to ask ourselves, what do they have in common? What they both have in common is a 3. What they both have in common is an x to the 2n plus 2. So basically you divided it by the 3, by the x and 2x, so we only have 1 left over here because we literally factored everything out of that one. When you factor 3 out of 12, you're left with a 4x to the n plus 1. Because we took 2 n's out of 3 n's, we're left with 1 n. Because we took 2 out of this 3, we're left with 1. So this is actually the answer to factoring exponentials. And we're going to be looking a lot at factoring. Let's look at the next problem. Same thing in this next problem is you might not look at how you could factor this, but when you look at the numerator, up there you actually have a difference, a minus sign, of 2 squares. Anytime you have the difference of 2 squares, you can actually factor that. What you have to recognize is the minus sign and the fact that both of these are perfect squares. And what do I mean by a perfect square? This actually can factor out to x to the a minus y to the b times x to the a plus y to the b. And that's what a difference of 2 squares factored out, and then you have it over x to the a plus y to the b. And what's going to happen here is x to the a plus y to the b is going to cancel, and you're left with x to the a minus y to the b, and that actually is your answer. Just a little factoring. The last concept that we're going to look at, it's kind of involved, but I actually think it's easy because it really involves very little math. It's all formula based, and this is going to be on page 142, 19.c. And what this is it's the sum and the difference of two cubes. And so some of the problems are going to be the sum of two cubes, where you get the cube plus the cube of a number. If it's the difference of two cubes, it's going to be the cube minus the cube of a number. In this first example that they give us, it's actually the difference, the minus sign, of two different cubes. And what they want you to do is break it down, and the way that, or factor it. And the way that you're going to factor it or break it down is by using these two formulas here. We will obviously use the bottom formula, and you want to write these two formulas on your formula page. We'll obviously use the bottom formula because it is the difference of two cubes. And the way that you do this is you start, and the answer will be everything that's to the right of the equal sign. You start by getting the cubed root of all these numbers. What is the cubed root of x cubed? It would be x. The cubed root of y cubed is going to be y. Not difficult on this one. And it would be p, the cubed root of p cubed. Now what you're going to do is you're going to take from this kind of base version of the problem, and then you're going to work it. So F stands for first number, and S stands for second number. So this would be the F, and this would be the S. This would be the first number, this would be the second number. So F squared, the first number squared, is going to be x squared, y squared. Plus Fs, so the two just multiplied together, will be x, y, p. And then S squared is going to be p squared. This is literally our answer. Really wasn't too difficult. You just have to kind of pay attention. Let's turn it up a notch by looking at something that has a little more complex numbers and letters. As you look at this problem, you're going to get the addition of two cubes. So you'll use the top equation. Once again, this is the F term, this is the S term, first and second terms. First thing you're going to do, we're using the top formula, which simply means the signs are going to be different, but the letters are still all the same. I want to break down the first term, so we're going to get the cubed root of 8, which is 2. The cubed root of m cubed is n. Cubed root of y to the 6th, remember we're dividing by 3 when you get the cubed root of an exponent. It's going to be y squared, plus the cubed root of x cubed is going to be x. So that is the first term. Now we're going to take the first, the base. Now we're going to take f and square it. So 2 squared is 4, m squared is m squared, y squared squared is y to the 4th, minus, you're just going to multiply these together, it's just going to be 2my squared x, plus the second number squared is going to be x squared. Once again, that is literally your answer. Lesson 20 is actually something we've already looked at in class, and Lesson 20 is something you're going to get from your class notes. I don't know if you can see that really well, but go to your pre-cal notes, and you're going to look at these trig functions. We can talk about these more in class. It's actually something you already did on the last test. Not too difficult at all, but we can work on these in class for Lesson 20, but it's simply two special triangles or looking at trig functions. It is in your class notes on the OneNote.